Today you'll be finding a quadratic model and interpreting it. Our first type of problem says a parabola contains the points 1, 0, 2, negative 3, and 3, negative 10. What is the equation of the parabola in standard form? The first thing you're going to do is you're going to plug each of the ordered pairs into y equals ax squared plus bx plus c. So if we look here, notice we're going to have 0 equals a plus b plus c, because 1 squared is 1, so 1 times a is a, b times 1 is b, and then we have plus c. Now we're going to do the same thing for the next ordered pair, 2 comma negative 3. Notice the resulting equation is negative 3 equals 4a plus 2b plus c. Now do a similar process for that third ordered pair, 3, negative 10. And you should get a resulting equation of negative 10 equals 9a plus 3b plus c. Now, notice we have an equation 1, an equation 2, oh, nope, I highlighted the wrong thing, an equation 2, and an equation 3. Now we're going to write a system of equations of 3 unknowns. So notice our resulting equation. Equation 1, a plus b plus c equals 0. Equation 2, 4a plus 2b plus c equals negative 3. And equation 3, 9a plus 3b plus c equals negative 10. Now we're going to solve this system of 3 unknowns. So you're going to choose the variable that looks easiest to manipulate. I would probably start with c if I possibly can, because they're all 1c's throughout each equation. With that being said, I'm going to multiply equation 1 by negative 1. And I'm going to rewrite equation 2 directly below it. Now let's add the two equations together. Notice we have 3a plus b, oop, I forgot my negative 3, whoopsies, equals negative 3. This becomes our new equation 2. Now remember, we're going to rewrite the system, and I'm going to use the same old equation 1 and equation 3 from the previous step. This time I'm going to take my new equation 2 and replace equation 2. And remember, I want the c's to cancel out. I still have to get rid of c through equation 3. So I'm going to multiply equation 1 by negative 1 again. Remember, the third equation is going to remain unchanged, so we just copy it. When we add the resulting equations together, we have 8a plus 2b equals negative 10. This is going to become our new equation 3. So note we took the system from the previous step and rewrote equations 1 and 2. Now I'm going to take that new equation 3 and put it in the equation 3 spot. Now, of equation 2 and equation 3, we're going to choose one of either a or b to eliminate. Well, hopefully you recognize it looks the easiest to get rid of b's. So we're going to multiply equation 2 by negative 2. Remember, we do not need to multiply equation 3 by anything, so we're just going to copy the equation. When we add the two equations together, notice we have 2a equals negative 4. A equals negative 2. And that is our new equation 3. So we'll copy old equation 1, the equation 2 from the previous step, and our new equation 3, a equals negative 2. Because in our system we have 3 unknowns, then 2 unknowns, and 1 unknown, all that's left for us to do is to do back substitution. When we do so, we do get b to equal. B will equal 3, and now let's find c. Hopefully you find c to be negative 1. Our third step is we will replace a, b, and c into y equals ax squared plus bx plus c. Okay, so remember we found A to be -2. We found B to be +3. And C we found to be -1. And there's our solution. Now I want you to take some time and try the example you tried. Hopefully you found y equals -3x squared plus 1x plus 0. Remember, you can just write it as -3x squared plus x if you would like. So now we're going to take this process and we're going to take it a step further and apply it to an application. So notice we have a player throws a basketball toward the hoop. The basketball follows a parabolic path through the points shown. If the center of the hoop is at 12:10, will the ball pass through the hoop? Well, the first thing we have to do is we have to figure out what is the equation of this parabolic path of the ball. So we're going to do the same process we did in the previous example. The first thing we're going to do is we're going to substitute the three ordered pairs given to us in the picture into y equals ax squared plus bx plus c. Hopefully you found the first equation to be 10 equals 4a plus 2b plus c. Now do the same thing with the next ordered pair for 12. Hopefully you found the next equation to be 12 equals 16a plus 4b plus c. Now do the same thing with the third ordered pair, 10, 12. And hopefully you find that third equation to be 12 equals 100a plus 10b plus c. So note, we have a first equation, a second equation, and a third equation. So now we can write our system of equations. That is our next step. So equation 1 is 4a plus 2b plus c equals 10. Equation 2 is 16a plus 4b plus c equals 12. And equation 3 is 100a plus 10b plus c equals 12. Okay, so again, notice the easiest letter for us to eliminate, it looks like C because it's all 1C's for each equation. With that being said, I'm going to multiply equation 1 by -1. Remember, because we don't need to multiply equation 2 by anything, we're just going to recopy it down. So remember, now we're going to add those resulting equations together. So our new equation 2 looks like 12a plus 2b equals 2. So remember, you're going to rewrite your system and you're going to take the old equation 1 from the previous step and the old equation 3. And remember, I'm going to put a new equation 2 in the equation 2 spot. And remember, the next step is to get rid of the c. So I'm going to multiply equation 1 by -1 again. And note that we just recopied equation 3 because we don't need to multiply anything by it. When we add the resulting equations together, notice that we do get 96a plus 8b equals 2. And this is our new equation 3. And remember, we're going to copy equations 1 and 2 from the previous step, and equation 3 will be that new equation 3. Now we have to either choose to get rid of A or B. It does not really matter. If it were me, I'd probably pick the one that looks easier, and I would probably eliminate B next and multiply equation 2 by -4. Remember, we don't need to multiply equation 3 by anything, and all we're going to do is add that resulting equation. Let's see, 48a equals -6, and a is going to equal -1/8. And if you think about it and look back at the basketball picture, that makes sense because when you throw a basketball, it is like an upside down parabola. This is our new equation 3. So we're going to rewrite our system. We're going to take our equation 1 from the previous step, our equation 2 from the previous step, and our equation 3, the new one. Now, because we have 3 unknowns, 2 unknowns, and 1 unknown, we can use back substitution. Let's do that next. You should get b to be 7 over 4. If I take 12 times negative 1 over 8, that does end up being 3 over 2. And then 2 plus 3 over 2 is 7 over 2, times 1/2 is 7 over 4. Now find letter C. And you should find C to equal 7. So all that's left for us to do is to write our model. So our model, we will have y equals our a, negative 1 over 8x squared, plus b, 7 over 4x, plus c, 7. Okay, so that's our step 3. Now, in step 4, what we'll do is we will plug in 12, 10 to see if the ball passes through the hoop. Okay, so here we go. 10 equals negative 1 over 8 times 12 squared plus 7 over 4 times 12 plus 7. And then I would type that right side exactly like I see in a calculator to see if it equals the left side. It does actually equal. And if it is a true statement, does that mean the ball passes through the hoop? Yes. We can say because this is a true statement, the ball does pass through the hoop. Now I want you to take a few minutes and I want you to try the next problem. Hopefully you find your system to be a plus b plus c equals 3, 4a plus 2b plus c equals 5, and 9a plus 3b plus c equals 6. Now find your model. So hopefully you find your model to be y equals negative 1/2 x squared plus 7 over 2x. Now remember, we still have to answer the question if the ball will hit the wall on the way up or the way down. So let's plug in 5, 6 to our model. And so here's our final answer. No, the ball will only reach a height of 5 when x is 5, which is lower than the top of the wall at 5, 6. So the ball will hit on the way down. And let's look at one more example. So we have the Gateway Arch in St. Louis, was built in 1965. It is the tallest monument in the U.S. The arch can be modeled by this function, where x and y are in feet. How high above the ground is the tallest point on the arch? Okay, so if you need to think about this, remember the St. Louis Arch. If you don't know what it looks like, it is something like this. And to find the highest point, the tallest point on the arch and how high above the ground, that means I want to find the y-coordinate of the vertex. So first thing we have to do is we have to find the x-coordinate of the vertex, h. And remember to do so, we're going to do h is negative b divided by 2 times a. So we'll take negative 4 divided by 2 times negative 0.00635. And we'll type that into a calculator. Make sure you use parentheses for the denominator. Hopefully you get something like 314.961. Okay, so after we find the h-coordinate, now we find the y-coordinate of the vertex or the value of k. And I would type that exactly like I see, including the parentheses, into a calculator. And hopefully you get something along the lines of 629.9192 feet. Okay, and that's what you would have to do for the first part. In the second part, we want to know how far apart are the legs of the arches at their bases. Okay, so in other words, we want to find x-intercepts. Okay. So in order to find x-intercepts, we set the y value equal to 0. And this is kind of pre-teaching what we're going to learn after we take this next formative, but I can factor out an x. And if I notice I do zero product property, then if I set this equal to 0, I already have x equals 0, and that's one of our intercepts. Well, that means this, when x is 0, I'm at the origin. Okay, and we already know this distance is 314.96. So we know parabolas are symmetric, so we know this value is 314.96. So all we have to do is double it. So our final answer, if I take 314.96 and multiply it by 2, we actually get 629.92 feet, which is eerily similar to the one we just found. What? The end. We are officially ready for practice. Yay!